So when you take alkyne like CH, double bond, triple bond CH, and if you treat it with ozone, we all know that CH will be like this. One of the oxygen will be bonded like this. The other two oxygen will be bonded like this. So now normally what we will do, we will treat it with water molecule. So this will go off and the bond will break here. So what is left out when that molecule breaks out? HC again CH. As the bond broke up at the top, the double bond will form here. This is called as glyoxal, or simply called as ethane 1,2 dial. But this molecule, if you further allow it to just stand in presence of hydrogen peroxide, the molecule breaks here. One of the OH adds up here, another OH adds, so you'll get H. You'll get H COOH twice, so which is nothing but methanoic acid. The IUPAC common name of ethane is acetylene. Similarly, you take another molecule called propyne and treat it with ozone. So what will you get? CH3C single bond CH. As usual, the ozonoid will be formed like this. So when you treat it with water molecule, this will go off and the bond here it will break. So you'll get CH3C single bond CH, double bond O, double bond O. What is the name of this molecule? One, two, three. So this molecule is called 2-oxo-propan 1-al. Again, what will happen? When this gets treated with a peroxide molecule, the bond breaks here. OH will be added. So you'll get CH3 COOH plus HCOOH. So what is the first molecule called? It is acetic acid or ethanoic acid. This is methanoic acid or formic acid. I am using common name and IUPAC name together. Okay. Copy ma. Finished, Amma? Finish copying, ma?
Yes, sir.
Good. Now let's go for the next reaction. Write down polymerization reaction. So when you say polymerization, there are two types of polymerization. Another one is called as linear polymerization reaction. Another one is cyclic polymerization reaction. When you say linear, that means it's going to be in a straight chain. So take 2 moles of CH, triple bond CH, acetylene, treat it with chlorine in presence of NH4Cl. You'll get something like vinyl acetylene. What is this called? Vinyl acetylene. Other way, you take acetylene, 3 molecules of acetylene, you take 3 molecules of acetylene like this: CH, triple bond CH, CH, triple bond CH, CH, triple bond CH. When you pass it through a red hot tube, the 3 triple bond, the 3 molecules exchanges the triple bond and cyclizes. So when it is passed through red hot tube at 873 Kelvin, what will happen? This bond goes here, this bond goes here, and this bond moves. So as a result of this, you will get something called a cyclic molecule like this, which is nothing but your benzene. Please make a note, ma. Finished, Amma?
Yes, sir.
Shall we move forward?
Yes, sir.
So the next one is the aromatic hydrocarbon. So when you say aromatic hydrocarbons, most of the time it is benzene and benzene-like molecules or substituted benzene. For example, so this is benzene. So you just substitute anything to the benzene. This is called toluene. Okay, or you take another benzene ring, you attach two methyl, we call it as xylene. Like this, we have the same molecule with different name when the substituent changes. So this is called as orthoxylene. So this is one set. No sir, I want to see different type of aromatic hydrocarbons where many rings are there. In that case, you will have polycyclic aromatic hydrocarbons like you have naphthalene, you have something called anthracene, so these are all benzene like aromatic hydrocarbon, but they have fused benzene rings. Copied ma?
Yes, sir.
So in the first reaction, they are saying first question C8H10. So we already know these xylenes, so we just added one ethyl benzene. So it's very easy for us to answer that question. Look at the next question. Write all possible isomers of C9H12, but they are saying it should be mono substituted. Last time we didn't have this problem, but this time they are saying it has to be mono substituted. So let us take the benzene ring. CH2, CH2, CH3. Check how many carbons are there. 6 plus 3, 9. How many hydrogens are there? 2 plus 2, 4. 4 plus 3, 7. 8, 9, 10, 11, 12. So balanced. Similarly, what is the other isomer possible? Same benzene ring. If I write it in bond line, I think you may not understand. So let me expand and write. So there are only two possible isomers. What is this called? This is called as N-propyl benzene. This is isopropyl benzene. This isopropyl benzene is also called as cumene. Please copy ma. Finished, Amma? Shall we move forward?
No, sir. Copied, sir.
Super. Now write down the next topic, very important topic, aromaticity. What is the meaning ma? Aromaticity na enna ma nenikiringa? Just by looking at the word, what do you understand? Hello? What do you understand
Yes,
from
sir.
the word aromaticity? The word படிச்சா உனக்கு என்னமா தோணுது? ஒண்ணுமே தோணலையா? அரோமேட்டிக்னா என்ன அர்த்தம்? மீனிங் என்ன அரோமேட்டிக்னா? புக்கெல்லாம் தேட வேணாமா? I'm just asking you. In general, if you say something aromatic na enna artham?
Or no.
You have never come across the word called aromatic? Aroma. Cherry, okay. So the word aromatic means something which has a good smell. But here the word aromatic or aromaticity means stability. So how do you define the stability? 3 conditions it should satisfy, ma. It should satisfy how many conditions? 3 conditions. Number 1, it should have a planar molecule, planar shape. When something is planar, it will have what hybridization? sp2 hybridization. This is number 1. Number 2, the pi electron should delocalize. Number 3, it should obey a rule called Huckel's 4n plus 2 pi electron rule. அது அக்கல்னு படிக்கக்கூடாது, யூக்கல் தான். Where n can be any integer. Where n can be any integer, 1, 2, it can go on. Any integer it can be. Finished, Amma?
No, sir.
Okay, copy. So what is the name of the rule? Huckel's 4n plus 2 pi electron. So the molecules which obey this particular 3 rules are aromatic in nature. Avla.
Copy, sir.
Super. Now let us take one example and we'll handle, ma. First I will give you the list of aromatic compounds in your textbook and then we'll go for non-aromatic or not aromatic compound. Okay. So what is this molecule called? Benzene. So is it a planar molecule? Yes. It is a planar molecule. Does that undergo delocalization? Yes. Ma, the diagram is not given in the book. You write it properly, ma. You copy it properly. Huh? Again, how many electrons are there? 1, 2, 3, 4, 5, 6. 6 electrons are there. So if you take the value equal to n equal to 1, then 4 into 1 plus 2. That means 6 electrons. So if you assume the value equal to 1, there are 6 electrons. Therefore it obeys Euclid's 4n plus 2 pi electron rule. So therefore you can just call this molecule as aromatic. Similarly, you take naphthalene. Is it a planar molecule? Yes, it is a planar molecule. Does that undergo delocalization? It does undergo. So what will happen here? This bond goes here, this bond goes here, this bond moves. So this bond moves here. So as a result of that, there is a double bond here, double bond here, double bond, and then there is a double bond. So that is naphthalene. How many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. If 10 electrons are there, n equal to 2. That means 4 into 2 plus 2 is equal to 10. Therefore, it obeys Euclid's 4n plus 2 pi electron rule. Therefore, you can label this molecule to be aromatic. Copy ma? Did you understood how am I calculating the pi electrons, ma? One bond of the pi bond will have 2 electron. So if there are 5 pi bond, that means 10 electrons. Okay, you understood that?
Yes, sir. Copy it, sir.
Superb. Now let's go for the next molecule. I'm just doing only the molecules in your textbook, okay? What is this molecule called? This is called as anthracene. And remember, it is also having it is a planar molecule, because wherever double bond comes, it is a planar molecule. Okay, how many okay, does this undergoes delocalization? Yes, it does undergo. I think in your textbook they have not given the delocalization form, so you copy it from the notes. So this bond shifts here, this bond moves here, this bond moves here, this will be here, this will be here, this will get shifted here. So what will you get as a result of that? Again, this will get shifted. So it will get shifted like this. So that is about anthracene. Finally, you can also calculate the number of electrons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 7 pi electrons. So totally 14 pi electrons are there. 7 pi bonds, 14 pi electron. That means n equal to 3. That is 4 3s are 12 plus 2 14. So 14 pi electrons. Therefore it obeys 4n plus 2 pi electron rule. So with this, what do you understand? The molecule is perfectly aromatic. So they are all looking like benzene. I think they will be aromatic. Give me an example where it doesn't looks like benzene, but still it is aromatic. One such example given in your book is this is called a cyclopropenyl cation. First point, all the carbons are sp2. Carbocation is also sp2, double bond is also sp2. So it is planar. So it is a planar molecule because all the carbons are sp2. What is the third point? It should be aromatic. It should be undergoing delocalization. Correct, Amma? So when this shifts here, the bond goes here and the positive charge moves here. Again, what will happen? Again, what will happen? This bond moves here and then the positive shifts here. So likewise, it can undergo delocalization. Now you check the number of electrons, ma. What is the number of electrons here? Pi electron? 1, 2. 2 electron. That means n equal to 0. So 4 into 0 plus 2 is equal to 2 electron. Please remember, it obeys Huckel's 4n plus 2 pi electron rule. So hence you can just label this also to be aromatic in nature. Copy, ma? Once you are done, let me know. We'll go for the next part. So in your textbook, they have given few examples. I'm going to take them alone. For example, you take this molecule. This is called a cyclopentadiene. Okay, this carbon is an sp3 carbon. So if at least one carbon is sp3, what will happen? Not a planar molecule. So first rule gone. What about the second rule? So in your book they have said it has a planar structure, but sorry, it will not have planar structure. Okay, so I don't know why they have given it. Cyclopentadiene will not have planar because sp3 carbon will always have what shape, ma? Tetrahedral shape. Padichirukoma? sp3 molecule will have tetrahedral, so it will not have a planar, but in your book they have mentioned planar. That itself wrong. Second thing, you just calculate the number of electrons, ma. 1, 2, 3, 4. So it is 4 electron. So it doesn't obey Huckel's 4n plus 2 pi electron rule. Okay, so because of these two reasons, this molecule is not aromatic. Don't use the word non-aromatic, it has a different meaning. So you just mention not aromatic. Next molecule, this is called as cyclooctatetraene. Okay, this is cyclopentadiene. This is cyclooctatetraene. Remember, this molecule is not planar as well. Though the molecule looks to be having a sp2 carbons, it is not planar. The molecule shape looks like this. Please copy this shape, ma. So it has a non-planar structure. Okay, so that is one thing. And then how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 electron means it doesn't obey Huckel's 4n plus 2 pi electron. So thus you can just say that it is not aromatic. Copy, ma. Done?
Yes, sir. Copy.
Now let's go for the preparation. What are all the various methods of preparing the benzene compounds or the benzene itself? So one reaction we already saw from acetylene. Just now we saw, right? From acetylene you can prepare the benzene cyclization, I told you, no? So this reaction. So this is one method of preparing only. This is one method of preparing. So you take a red hot tube and heat it to 873 Kelvin, you get benzene. So this is one preparation method which we have already seen. I don't want to repeat it again and again, so I just copied it. Other than this, we have other methods, like you can prepare it by a decarboxylation method. What is decarboxylation method? Take C6H5COONA plus you treat it with sodium hydroxide in presence of calcium hydroxide. So you just remove this. You will get Na2CO3, and what is left over? C6H6 benzene. This combination of CaO plus NaOH is called as soda lime. Please make a note. This combination of sodium hydroxide and calcium oxide is called as soda lime. This is sodium benzoate. This is benzene. Copied, Amma?
Copy, sir.
Now let's go for the other reactions. Write down. There is something called Wurtz fatigue reaction. So you take a benzene ring. Let me take a simple bromobenzene treated with 2 molecules of sodium, and you had another molecule called bromomethane. Remember this reaction to be carried out at dry ethereal condition. So what will happen? 2 moles of NaBr you will get. Finally you'll get benzene ring with bromide. We call this as with methyl. We call this as toluene. So what we took was bromobenzene and bromomethane, but what we get is toluene. Similarly, there is another reaction which is called as distillation of phenol. You have to do nothing, just take the benzene ring with OH. You have to just add zinc and you have to do continuous distillation. So what will happen? The zinc will take the oxygen and becomes zinc oxide, and finally you will get benzene ring. So this is phenol, this is benzene. Make a note, ma.
Copy, sir.
Now write down, ma. Next, last reaction or the last preparation of aromatic hydrocarbons. We call this as Friedel-Crafts reaction. We are going to see the mechanism now. So you take the benzene ring and you treat it with CH3Cl in presence of anhydrous AlCl3. So what will happen? This hydrogen will take the HCl and forms HCl. Thereby you get benzene ring with a methyl attached to it. So what is this molecule called? Benzene. This is chloromethane. This is toluene. There is one more question in the evaluate yourself. They are asking, how do you prepare benzene from Grignard's reagent? So I'll write that reaction also. So when you say Grignard reagent, this is benzene, magnesium and chloride. We call this as phenyl magnesium chloride. Phenyl magnesium chloride is an example of Grignard's reagent. You need not do anything to it, ma. Just add water. If you just add water to it, it will take care. So you break, the bond will break here. You'll get HOH. MgClOH plus benzene ring. And this reaction is very, very dangerous reaction. So the reaction violently react. Vedichiro, actually speaking, if you are going to add water to Grignard's reagent. So it will violently react. Please make a note, ma. So when you say physical properties of benzene, please make a note. Benzene is a colorless liquid which will be insoluble in water, but it will be soluble in solutions like alcohol, ether and chloroform. That's what we normally think, right? Benzene is non-polar, so it will be soluble in water. No, benzene is insoluble in alcohol, ether, chloroform or water. Whatever you take, it will be insoluble. It will form a separate layer because benzene itself is solvent. That is one point. Another thing, it burns with a very luminous sooty flame because of its unsaturated double bond and gives various alkenes and alkynes. Okay, and because of the double bond, normally what we think, it will liberate soot. No, it will give a clear what you can say, a clear flame, clear bluish flame you will get. So the vapors are highly toxic and it has to be burnt, or it has to be tested in a very controlled condition. You cannot keep it open. If you inhale, you may become unconscious. Remember, when I talk about the chemical property, the first thing that should come to your mind, it undergoes, please make a note, electrophilic substitution reaction. So you take the benzene ring and see what all it can react with. So all the reactions, what am I going to show now? They are all electrophilic reaction. So first you treat it with HNO3 in presence of H2SO4 at 330 Kelvin. You will get benzene ring with a nitro group attached. We call this as nitrobenzene. Similarly, if you allow it to react with chlorine in presence of FeCl3, you'll have benzene ring with a chloro group here. This is called as chlorobenzene. Similarly, if it reacts with H2SO4, constant H2SO4, we'll get benzene ring with SO3H. We call this as benzene sulfonic acid. So similarly, if you take anhydrous AlCl3 in presence of CH3Cl, we'll have benzene ring with a CH3 attached to it. We call this as toluene. Similarly, it can react with anhydrous AlCl3 in presence of CH3COCl. You get a benzene ring with COCH3, which is nothing but acetophenone. Write down all these reactions are electrophilic substitution reaction. We are going to see the mechanism now. Okay. So is that clear, ma? Step 1, generation of electrophile. Step 2, rhenium ion mechanism. Step 3, regeneration of catalyst or deprotonation. So let me go to the first reaction. What is the first reaction that we wrote? Write down step 1. What is step 1, ma?
Generation of electrophile.
So நீங்க எழுதிக்கோங்க ma, you write generation of electrophile. So I am writing HNO3 in this form and I am writing sulfuric acid in this form. Please make a note. So they both react together and form H2O plus HSO4 minus. So what is left over, ma? NO2 plus. So the name of the electrophile is nitronium ion. Step 2. What is step 2, Kana?
Rhenium ion.
Correct. Rhenium ion mechanism. So treat it with NO2. So the electron from the benzene ring will attack. Okay, not the reverse. So what will happen? Draw the benzene ring. The double bond is here. Hydrogen is here. And NO2 is attached. But there is a positive charge here. So this positive charge will not be quiet. So it will be moving. And it gives you a structure like this. So this ion is called as rhenium ion. All the three are separately called as rhenium ion, or together also it is called as rhenium ion. How will you write it together? So draw the benzene ring with an hydrogen, NO2 outside. Since there is a positive charge, you will put a plus charge inside. This is what rhenium ion is. Right? Now let's go for the step 3. What is step 3, ma?
Regeneration of catalyst.
Or
Deprotonation.
Paklama, whether it is happening or not.
Yes.
So what is getting lost here? The proton is giving its electron. Okay. And what was there in the first step? HSO4 minus was there, right? Add that also. So this HSO4 minus will take the proton. So you'll get minus H2SO4. So the sulfuric acid is regenerated. At the same time, nitrobenzene is formed. So this is about nitration. Copy, ma?
Copied, sir.
Copy, Rama. Now let us go for the next reaction. What is the next reaction, ma? Huh? Next reaction என்னன்னு கேட்டமா?
Halogenation.
புரியல.
Halogenation.
Very good. It is called as halogenation. So step 1 enna? What is the step 1? Same. Nothing is going to change. Yeah. Step 1 is regeneration of electrophile. So we have FeCl3, Cl and Cl. So what will happen? This chlorine gets added up to this. So you'll get FeCl4 plus Cl plus. What is this called, ma? Chloronium ion. Same thing, ma. Nothing is going to change. Everything is going to be the same. Only in place of nitro group, chloro group will be there. Check. Again, in the final step, in place of HSO4 minus, you will have FeCl4 minus. Here you will have chlorine. So you'll get, instead of FeCl3 is formed, HCl is also formed. Along with it, you'll have chlorobenzene. Copy this, ma. This is called halogenation reaction. Again, step 1 is called as generation of electrophile. Step 2 is called as rhenium ion mechanism. Step 3 is called as regeneration of catalyst. Clear, Amma? Any doubts?
No, sir.
Finished, Amma?
No, sir. Copied, sir.
Good. Next reaction is called as sulfonation reaction. So the next reaction is called as sulfonation reaction. Again, what is the step number 1 here? Any idea? Huh?
Generation of electrophile.
Exactly. Generation of electrophile. Paklama, how to generate? HO, SO3, OH plus another molecule of H, HSO4. So now what will happen? So one will be HSO4 minus. Our electrophile is SO3. So what is left over, ma?
H2O2.
That is the mistake we did. We took only one hydrogen extra we took, you saw. So what is left over? If you check what is left over, 1H. So how do you write this? H3O plus. So this is your electrophile, and make a note. Sulfur trioxide is a neutral. Sulfur trioxide is a neutral electrophile. Okay. So again, what is the step number 2? Arrhenium ion mechanism. Okay. SO3. So this attacks here. So you'll get SO3 minus. SO3 minus. SO3 minus. So SO3 minus. You'll get arrhenium ion. Step number 2. You have to take all of them, okay? Step number 3, you have to take all of them. So I'll write all together. First thing, you have to take the H3O plus. Next, you have to take the HSO4 minus. So it takes the proton and becomes H2SO4. And the SO3 minus is there, no? So what is attached here? SO3 minus. That will take the proton and thereby you get water. So minus H2SO4 minus water will get benzene ring with SO3H. We call this as benzene sulfonic acid. Copy ma. So with this we'll conclude for today ma. So next class we will continue with the remaining reactions. Okay. So any doubts in today's session ma?